Please welcome Mr. Nimesh Chinoy. With 2 decades of application engineering experience in welding and induction heating, Mr. Chinoy has authored and presented over 100 technical papers on welding, induction heating, and IoT Industry 4.0 for welding at national and international conferences. Currently serving as the Honorary Secretary of the Association of Welding Products Manufacturers. He is a crucial member of the BIS Electric Welding Equipment Sectional Committee and represents the ICM in the Central Council for the Indian Institute of Welding. Additionally, he plays a pivotal role in the core committee of welding for the CII. Mr. Nimesh Chinoy will talk on energy efficient welding processes. So let's welcome Mr. Chinoy.
So today we'll be talking about energy efficient processes. I'll just give a little brief about electronic devices. We have 49 years of experience, 287 dedicated employees with exports to more than 80 countries and 10,000 plus happy customers globally. With the motto to making things happen for our customers, we have our products categorized as induction heating, induction sealing, and welding and related automation. Let's quickly get into the processes that are commonly used. And I believe today's topic is more focused on the infrastructure. In the infrastructure, we use a lot of arc welding applications, MIG-MAG, and submerged arc welding. There are also a lot of new developments to do with laser welding, friction stir welding, plasma arc, PTA, and strip cladding. But these we will not be touching for the part of it today. If we quickly look at the deposition comparison of deposition rates for different processes, you can see there's the highest amongst them on the standard processes, single wire submerged arc, ranging from 3 kgs per hour to about 16 kgs per hour. And if you look at the flux core wires, welding is 1 kg per hour to 15 kgs per hour. MIG-MAG goes from 600 grams per hour to about 12 kgs an hour. And arc welding, which is the most traditionally used, starts from 0.4 or 400 grams to 5.5 kgs an hour. The most commonly used process is arc welding even today in India and mostly globally as well. If you want to increase the productivity and increase efficiency in these equipments, you need man, machine, and consumable, all three to be improved. If you look at the man, arc welding needs a welder. It is rarely be automated process. It's a non-automated process. For slag removal and spatters, you need to have chipping and grinding. You can improve this by upgrading to inverter-based machines from the traditional machines such as transformers and rectifiers. This will help reduce spatters, make cleaner slag removal. Also, energy saving is a bonus. You save close to about 30 to 60% energy if you move to inverter-based from the traditional equipment. Most commonly used electrodes are 6013, 7018, and for pipeline root welds, they use cellulosic electrodes such as 6010, 7010. If you're using arc welding, you can move over to manual or semi-automatic MIG-MAG, flux core wire, or thin wire SAW to increase your productivity and efficiency. If you move from arc welding to MIG-MAG welding, the bottom first 3 electrodes that you see, 7018, 6010, and low hydrogen, you can see the deposit rates between 0.65 to 1.18 kgs. And if you move upwards towards semi-automatic flux core welding and all the way up to automated MIG-MAG dual torch, you can go up to 7.5 kgs per hour. So that's the progression depending on the job, depending on your level of automation you want to use. You can easily go from 600 grams to at least a semi-automatic flux core welding of about 2 kgs an hour, or a mechanized trolley to take it up to 2.5 kgs an hour. When you move from arc to flux core, you need to keep into mind that you're moving from a manual process to a mechanized process. Your investment cost will be slightly higher compared to arc welding. Your metal recovery will be very high. That means per kg that you pay, you will have more deposits, no stubborn losses. And of course, you can use gas-based or self-shielded wires. And it will be mainly used for filler and capping runs, whereas the basic root runs may still be done with arc welding or TIG welding. Here you can see the geography changes. If you're doing arc welding traditionally, you would use a bigger V. And if you go for mechanized, you can have a smaller V. That means less amount of material, more amount of throughput, right? So you can increase your ROI by 2.5%, with 2.5 times, because the process is that much faster. And you can have more metal per kg deposited, more metal per hour deposited, and the process can be easily mechanized. This is what a arc welding or a flux core MIG welding machine looks like. You can go for single or twin wire both. Just a comparison, if you wanted to see per kg, you can look at the saving is about 80% of pre-aging cost can be saved. And if you look at using metal cord wires, about 80% of time and cost saving happens. So these are different figures for used for the forging industry for die casting applications. If you wanted to increase productivity in arc welding, it is possible to do structural welding, PEB fabrication, pipe to flange, pipe to forging die repair, hard facing applications. You can automate them by moving to MIG-MAG or flux core wires using magnetic trolleys and with weaving units. If you move from arc welding to thin wire submerged arc, you could increase your productivity very fast. And this is very effective for low thickness, that is 5 to 15 millimeters, which is largely used in the infra sector for PEBs and girders and bridges, as Savant was sharing. So speeds up to 7.5 times arc welding can be increased. And it's a already established procedure used in PEB, that is the pre-engineered building applications of 10 to 12 mm thickness, also in pressure vessels for fill and capping passes up to 5 to 10 millimeters. Just a couple of photos, videos to show you how it looks. This is a 6 mm pressure vessel being welded using thin wire SAW. Here you can see small girders being made, flanges being made by using thin wire SAW. The wire sizes are between 1.2 to 1.6 and specialized storages to reduce the amount of setup time. SMAW productivity improvement, you can see already we've discussed. From thin wire, your productivity increases 7.5 times, and it's very good for low thickness up to 15 mm plates. Most popular process is MIG-MAG or GMAW welding, gas metal arc welding. It's widely used, extensively used in the automotive and heavy fabrication sectors. The advantages are very high speed. It can be easily automated, higher metal recovery, no stubborn losses. You can use self-shielded or gas-shielded wires, and you can also have narrow gap preparations. Although the challenges, as also shared by Dr. Satish Sawant, was that it requires a lot of skilled welders, and availability of skilled workers is a challenge. Welding root runs are not permissible in pressure vessels using this process. Thin sheet welding can cause burn-throughs. Penetration levels need to be cross-verified, and post-weld work spatter, cleaning, and grinding can be higher. And following WPS by the contractual welders can always be a question mark. To improve productivity, we can use high-end power sources, which is synergic, pulsed, and advanced power sources, 100% duty cycle. They're modular in nature. They can give you inbuilt intelligence, IoT, etc. Easier to train welders with, and low-skilled welders can perform better. More arcing hours per shift can be achieved if you move for high-end power sources. Simpler automation such as rotators, headstock, tailstock, semi-automatic parts can be welded on these. And long seamers are used with motorized slides, trolleys, so that you can do smaller shells. As we saw, the flanges and girders can be welded with them. Synergic machines have two basic steps. You can choose the material and the wire size and the gas, and it will calculate all the other parameters for you, thereby taking away the skill from the welder and putting it right back into the equipment. You can have basic programs such as soft arc or faster process. We call it DAC-MD in the Pro series that Sigma Weld has. You have jet arc for very high penetration, and you have root for better short circuit control. We'll see a little bit more on that. If you look at this mechanized GMAW process, this is for a manual one, many passes, not very clean. You have to clean after each pass. If you go for metallized flux cord wire, a narrower groove, lesser material to be deposited, and fully mechanized, you can see the number of passes is reduced drastically. Less number of passes, more weld deposit, and lesser cost overall. Of course, there's a different talk altogether depending on IoT and Industry 4 and how it can help you. But that's today a norm. We call it Weld Web, and we can give you a lot of analysis of data on that, which shows about the productivity, efficiency, and the consumption of the resources utilized on the shop floor. Of course, Root welding can also now be done with MIG welding instead of arc welding. This can help you with a lot of speed improvement. This is a proprietary software which allows you to have very high controlled short circuit. So you can see the waveform and the deposit of the, the breaking of the wire is very smooth, no spatters. And just a quick video to show you, how this looks in real time. So this is a pipe with the root weld being welded by the welder. You can see the root gap is larger and the welder is directly welding the root through this process. This process has now been accepted in the pipeline industry and it saves a lot of time. So it's ideally suited for root welding, consistent sidewall fusion, lesser weld spatters, tolerance to fit up conditions, also more tolerant to changes in stick out, tip to work distance, and the machine automatically accommodates for it. Lesser time to train the personnel and thicker root passes to eliminate hot pass. This is how you can increase productivity in MIG welding by using pulse MIG, different programs to give you faster productivity. You can use magnetic trolleys, weaving units, or multi-axis SPMs or robots to give you faster productivity. Of course, TIG welding being one of our core focuses to improve the speed in, because it's one of the best processes, cleanest, most good-looking beads, no spatters, all position welding possible. It's also possible to automate. However, it comes inherent disadvantages of being slow, having poor arc stiffness, low depth of penetration, higher heat affected zone, and of course, you need skilled welders. Can result in stubborn losses. Due to all this, it's considered to be an expensive process. However, there are tools that help you make this easier. You can go in for cold wire feeders, which are single wire, twin wire. They look something like this. They use a full spool. So you have 10% saving on material costs because you have that much less stubborn losses. You can increase your weld speed by up to 30 to 40%. And it allows a lot of, because there are less number of start stops, the number of grinding reduces, the amount of gas consumption reduces, and the operator convenience is much higher. The same operator can produce close to about 30 to 40% more speed. You can even preheat the wire before welding. That's called a hot wire TIG. And that can even help you with a lot of, speed increase in semi-automatic as well as fully automatic solutions. Comparatively, the productivity that you can get with cold wire or hot wire, typically if you take a 200 ampere range, you're doing about 10 grams per minute, or you can take it as 600 grams per hour. In cold wire, the same hot wire can give you close to about 1.8 kgs at the same current levels. So increase in productivity while keeping the currents low. You can use it with a pen right mounted onto the torch itself, or hot wire as shown on the third figure. This is easy to retrofit on your existing setup. So it helps you, it helps you use your existing setup of TIG welding machines. You need not invest in newer setup. It can be integrated with any old equipments, whether it's a European or an Indian or an old machine, it can do the works. Here you can see the productivity improvement is close to 25% and time taken is reduced by about 27%. You can also use twin wire, but this is usually used in automated setups. And in those cases, if you use twin wire with hot wire power sources, 150% improvement in deposit rate. This is something that you can use. It's largely used in cladding applications where a lot of material has to be deposited. Challenges to automate TIG welding: you have, edge preparation issues, grinding versus beveling, root face tolerances, mismatch in fit ups, ovality, and odd shapes. They can be taken care by using different kinds of weaving and oscillators, angular or straight. Some videos, but I'll play them later. You can also adjust the weaving speed, the dwell time on each end to avoid the lack of fusion, and you can set the weaving distances. Similarly, you can use something called an AVC or automatic voltage corrector, which follows the path by controlling the voltage, and it allows you to have very clear, irregular shapes can be managed by this as well. Few examples of welding automation: you can do pipe to flange, pipe to pipe, long seam, sud seams, ID/OD welding. It's all possible if you mix these three together: cold wire feeder, hot wire feeder, AVC, and weaving. Multiple combinations can be done based on your exact requirement. Some of the examples you can see. The leftmost, it's an 8 millimeter pipe to pipe joint reduced to 2 passes. Here you can see in the middle large spooling which have been done. And on the right, we are proud to say this is the Chandrayaan 2 and Chandrayaan 1 and Chandrayaan 3 outer solid fuel boosters which have been welded on Sigma weld setup. Cladding components, so if you had to overlay a component for oil and gas, you need to add Inconel, Monel, stainless steel, over carbon steel. These can be done in automated solutions using auto TIG, reducing a lot of time and giving you very good quality. These are 12-meter long pipes done with single head, 12 head, twin head, or quad heads together. Again, TIG welding, very consistent deposit, and high productivity rates. A lot more examples for automated TIG welding, but if there is any specific one that you need, we can discuss that. Speeding up TIG to a different level where you call it SWAT, Sigma Weld Accelerated TIG, wherein we create a keyhole, narrow the arc, and go more deeper. The arc force, when you narrow the arc, is so high, it's almost 3 times the regular TIG welding arc force. This allows you for more than 20% more penetration, and you can have square butt welds up to 10 to 12 millimeter for materials such as stainless steel, low alloy steel, titanium, Hesta alloy, difficult to weld alloys. You can do all of them. And since you don't use any filler wire, the base metal and the weldment have almost same tensile strength. So a very good welding quality, very high speed possibilities. It can be used for long seam, circular seam applications, tube mill applications. So this is how it looks. Basically, you can see a square edge preparation. There is no V shape done. It's a regular TIG torch, but it's going to be mounted onto the SWAT mode. It will punch it through the entire system in one go. You can see the efflux plasma exiting from the other end, which means there's a clean 100% penetration joint. And the welding speeds are upward of 400 millimeters a minute. So 8 millimeter thick plate can be welded very, very quickly. These are tube mill examples, which have done from right from 3 millimeters all the way up to 8 millimeters, continuous weld. If you look at the time consumed for a 1 meter stainless steel plate, if you to do manual TIG, it would take you about 102 minutes. Automated GTAW, 50 minutes, and SWAT, 5 minutes. That's the kind of efficiency you can get. Not to mention no use of any filler material. So this is a 6 millimeter plate welded on top of it. On the left, you can see the done with the second pass of pulsing, first pass 100% root joint. You can see the penetration here. And when we talk about efficiency, this rolled shell of about 1.6 meter length was welded in under 4 minutes. Typically, if you were doing this process manually, it was a one shift job, that is an 8-hour job. And on automation, it takes close to about 1 hour to do this, or at least half an hour with setup time and all. We've reduced the time for our customer to less than 4 minutes, and it's 90% reduction in consumable, and it's an impact minus 196, tested joint. So it's very high quality, no root pass required, no edge preparation required, and a single pass welding. So the increase of efficiency goes from up to 83%. Filler matter saved 90%. You don't have to clean weld passes, so you save 83% there. Weld edge preparation is not required, so 100% of that time is saved. About 60% gas is saved, and total cost per meter can be reduced by about 70 to 75%. This is extremely good for stainless steel, nickel alloys, and difficult to weld alloys. You can see for titanium as well. And this is for Hesta alloy, 6 meter long shells. The live welding feed, it moves at about 418 or 420 millimeters a minute. And it passes all the requirements of ASME Section 9 as it qualifies as TIG welding. Some of the macro graphs for 8, 10, and 15 millimeters. If you see 10 millimeters is in a single pass, 15 is done in 3 passes, 1 on the top, 3 on the bottom, total 4 passes. So that's all that I wanted to present on the speeding up of standard processes.
Thank you, Mr. Chinoy, for highlighting the crucial role of energy efficiency in the welding process.